Today's notes are on 1.5, solving equations by graphing. When you are solving an equation, means you're finding the values of x that make the equation true. You can solve using graphs. So here are the steps. The first step is to set each side of the equation equal to y. Set each side of the equations equal to y. Next, we're going to graph both equations. Graph both equations. And then we're going to find the points of intersection. So find the points of intersection. Now, the x's are the solution. So the x's are the solution. All right, so let's do some examples here. We're going to solve negative 3x plus 20 equals 5, but by graphing. So I know you guys could do this algebraically. Just do it algebraically to check your answer. So the first step is to set each side of the equation equal to y. So right here, I'm going to go ahead and that's going to be y equals negative 3x plus 20. And this right here is going to be y equals 5. Now, we should do this on graph paper, but I don't have graph paper on me right now. On my y scale, I'm going to go by 20. I need to go all the way up to 20 because that's my y-intercept, because that's mx plus b. So I need to make sure I hit at least 20. So let me go by 5s and kind of space them out. So that'd be 15, 10, 5. So this is your y-axis. On my x, I'll go by 2. So 2, 4, 6, 8. Now right here, your y-intercept is at 20. Now when you go down 3 over 1, and then you're going to go down 3 over 1 again, if I keep doing that, I'm actually going to cross the 0.55. So then here's my straight line. So this is the line of y equals negative 3x plus 20. And then the line y equals 5 is this horizontal line right here. So this right here is the point of intersection. So the solution is only the y value. So right here, my solution, is the x value, x value. Another way I could have done this is I could have used Desmos. And I could have graphed these. I'll go and I'll use Desmos on the next one so you can see it. Let's do another example. This time we're going to have x squared minus 8x plus 5 equals x plus 3. So right here we have a parabola and then we have a line. So I'm going to set each side equal to y. So this is going to be a y equals x squared minus 8x plus 5. And this is going to be a y equals x plus 3. So let me go on Desmos.com. So let me share my screen. And make sure you type this in one of them and this one in the other. So share screen. Here's Desmos. So in one equation, you're going to hit x squared. So you can hit x. The exponent key is down here. There's a square key right there. And then I need to hit minus. So minus 8x plus 5. And then in the next equation, let's lower that, is going to be an x plus 3. Plus 3. So here's our graph. And we can go ahead and we can zoom out. So I see the 2 points. So the red graph is the parabola, the x squared minus 8x plus 5. And then the blue line is the straight line, the linear, which is x plus 3. If you hover over and you click on it, it actually tells you the point of intersection. So right here, the x is going to be a 0.228. And then right here, it's going to be at 8.772 right there. So that's going to be your solution. It's going to be that value, the 0.228 and the 8.772. I'm going to go and I'm going to sketch what I got. This one right here was the parabola that looked like this. And then this was the linear. And the first point that it intersected, it was at 0.228, 3.228. And this point was 8.772, 11.772. Now remember, your solution is only the x value. So my solution here is x equals 0.228. And the solution on this side is that x equals 8.772 because the graph crossed 2 times, those 2 points of intersections. All right, next let's go into inequalities. When you are graphing inequalities, if you do not have the line on the bottom, so you have a less than and a greater than, these lines are going to be drawn with dashed lines. Which means not included. If you have the line on the bottom, those are drawn with solid lines. This is what you guys are used to, which means included. Equal is with a solid line. So we're going to go ahead and we're going to graph x squared minus x minus 12 is greater than 0. I'm going to go ahead and I'm going to use Desmos to plug this in to see what it looks like. So that's an x squared minus x minus 12. As you can see here, it crosses the x-axis at -3, +4, and it crosses the y-axis at -12. And then it has a minimum value down here. So I'm going to go ahead and I'm going to sketch this graph right here, but I want to make sure I label these points on there. All right, so let me sketch those. So at an x-intercept at +4, so 1, 2, 3, 4. Add another one at -3, so -1, -2, -3. It crossed the y-axis at -12, so -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. and then at a minimum at a half and a little bit down. So is at 0.5 comma negative 12.25. That was the minimum. So it looked like this. And we're going to draw it with a dashed line because that is the greater than symbol with no line on the bottom. So we need to make sure we draw it with a dashed line. At the minimum, it starts changing directions. Now keep in mind that your solution is going to be basically the X values. I just separated my X line into 3 sections. Here's one section, here's another section, here's another section. I'm going to test a point and see which region is true. And I'm going to test it into the equation right here. I like to test the point 0, 0. So basically, if the point 0, 0 is true, all of this is all going to be shaded. If 0, 0 is false, I have to shade the outside boundaries of it. And you have to test a point that is not on the line. So right here, I'm going to test 0, 0. So I have an x squared minus x minus 12 is greater than 0. The only number I have to actually plug in here is x. So everywhere I see an x, I'm going to plug in the number 0. So this is going to be a 0 squared minus 0 minus 12. That's going to be a negative 12. That is not true. That is a false statement. So because this is false, you do not shade the inside of the region. You're going to shade the outside of the region. And you can go ahead and you can plug in a 5 and it's going to come out to be true. You could plug in a -5 or a -4 and that's going to be true for this statement. Now, the way that we represent our answer, we only care about the x's. So basically on the x, you are going from negative infinity to -3, and then it's going to stop and jump to 4 to positive infinity. So basically on this side, x has to be less than -3 or x has to be greater than 4. Let's do one more example. Last one. Let's say we have a 1/3 x minus 10 is less than or equal to 3 minus 4x. That's going to be drawn with a solid line because you have the line on the bottom. So I'm going to go ahead and I'm going to type this into my y. That's a 1/3 x minus 10. And this is going to be my next y, which is a 3 minus 4x. I'm going to go ahead and plug these into Desmos and see what they look like. So the first one says 1/3. Now, if you hit 1 divide 3 and it automatically divides, just make sure you hit the arrow to the right to get out of the denominator. All right. So right here, let's see. They intersect at the point 3, -9. This one crosses the x-axis at 30, and this one crosses the x-axis at 0.75. So let's go ahead and let's sketch this. That's gonna have to go all the way down to 10. That's gonna have to go up to 3. 5, 4, 3, 2, 1. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Let's see here. Because I knew it cost at 30. So I don't want to draw 30 lines. So here's 5, here's 10, here's 15, here's 20, here's 25, here's 30. So this one right here, it was down here and it also crossed at 30. So it looked like this. This is the line y equals 1/3 x minus 10. Right here, this one crossed at 3 And then they intersected at 3, -9. I should be using a ruler, but I use Desmos, so I know what it looks like. Okay, now keep in mind, you are looking at the x's. Now, that's not the x that you're looking at. You're actually looking at the point 3, okay? Because 3 is where they intersect. So you're basically, your number line is going to be blocked into these two regions. So because that is your intercept, I need to test a point on this side and I have to test a point on this side. It has to be one of these regions right here. Okay, the X is where you're looking at because that's the point of intersection. So I'm going to go ahead and I'm going to test 0, 0 again. Because you remember, your solution is an X value. So when I test 0, 0, the equation says 1/3 x minus 10 is less than or equal to 3 minus 4x. So the x is going to be the value 0. So I have a 1/3 times 0 minus 10 is less than or equal to 3 minus 4 times 0. This is going to be a -10. This is going to be a 3. That is actually a true statement. So that means that the 0, 0 is going to be true. The 0, 0 is going to be true. And remember, the point of intersection was at 3. So that means everything to the left of 3 is going to be shaded. And because you have the line on the bottom, this is going to be closed. So my solution here is going to be x has to be less than or equal to 3. And that concludes our notes.